So,
No, ma'am. Screen is not visible.
so can you all see the screen now? I'm sharing a black screen.
Yeah. Black screen is visible.
Right. So let us talk about the container orchestrator tool. We were talking about the container orchestrator tool, right? So earlier we have learned Docker Swarm. Now we'll be learning Kubernetes, another container orchestrator tool in the same category. In short, we'll refer this as K8s. The name came in with these 8 letters, and hence in short, we call it as K8s, but it's like Kubernetes. So what is the difference? Both are container orchestrator tools, and there is one more tool which is Mesos from Apache, but it is very less used. We don't use it or hear much about it. It's from Apache, container orchestrator tool. So any container orchestrator tool will have these basic things like high availability, load balancing, scaling. Also, we have many other features like rolling updates, rollbacks, and so on. Rolling updates, rollbacks, and so on, right? These are all some of the container orchestrator features, out of which we have seen these basic things with the Swarm. But anyhow, we'll see all of them with Kubernetes. And like out of Swarm and Kubernetes, Kubernetes is very widely used, very extensively used. It's a far advanced tool because of the features or because of the architecture it has got. It has got a lot of importance and reality. Kubernetes is very widely used in the projects to achieve all of these features. And first, let's start with the differences between Swarm and Kubernetes. Let's begin with the basic differences. Swarm and Kubernetes. Swarm is a product from Docker. Kubernetes is from Google. It's a Google product, natively developed and managed by Google, now managed and maintained by CNCF, Cloud Native Computing Foundation. Right? And the Swarm, you don't need to install separately. You remember, right? We run the command Swarm in it and we get started with the Swarm cluster. But Kubernetes setup is a bit different and a bit complex, and it varies from environment to environment. Like it's a different in on-prem, it's a different in cloud, AWS, on GCP. The setup varies and differs. We will learn and get a clarity on how those different setups work, right? And then Swarm commands are very simple. They are like Kubernetes commands. Sorry, they are like just Docker commands, right? But Kubernetes, like it uses a different, like the commands are whole different, right? You'll have a kubectl apply. We'll use some utilities called kubectl, kubeadm kind of, and we'll do. The thing is, commands are different, and also we prefer to use declarative approach rather than imperative approach. Imperative approach means we run the commands for one-time use. That is there, but declarative approach is more preferred and more widely used in Kubernetes, right? And this declarative approach, we'll write the manifest files. Those manifest files are written in JSON or YAML. We prefer YAML again. Those are the basic differences, and the Swarm is very easy to learn and understand. Kubernetes, yes, that's a complexity is there in understanding, but it's very interesting and very good tool which help you manage your infrastructure, deploy your applications in production, right? So these are the very basic differences at the moment I can talk about. We will see many other differences as we progress or deep dive into the topic. Okay, so let's begin with Kubernetes architecture.
Uh, Kubernetes is Google products, and what is CNCF?
It's initially product of Google, but now it's managed and maintained by CNCF, Cloud Native Computing Foundation.
Okay.
let us look into the Kubernetes architecture. Swarm architecture is very simple. You have a manager and some worker nodes. Manager will maintain the cluster, but these are the worker nodes. Worker nodes will run the containers, right? So now let's look into Kubernetes architecture, which is a bit different. So here also again you have a master node. This is called master, right? We call it as a master node. Just a second. Okay, so this is the master node or the manager, right? We call it as managed in Swarm, but here we call it as a master. Master is called the control plane. It is also called as control plane of the entire cluster, which is like a decision maker, right? This is the one which will take the decisions of what should be, what container should be running on which worker node and all. But just understand this master node is called the um, this is called the master node, which is called the control plane of the cluster. And then these are the worker nodes. You can have any number of worker nodes. This is one of it. So let's go through the components which a worker node has got. It will have certain components like the first component is kubelet, right? What is this kubelet? Kubelet is nothing but the Kubernetes agent running on every node, right? It's like Kubernetes agent running on every node. Every worker node will have this kubelet running. Means if this master has to communicate with the worker node, kubelet is the component which takes the instructions from the master and execute those instructions. So kubelet is the first most component which runs on every worker node. Okay, and then the Docker. This is a Docker runtime. See, you are going to run containers, means container runtime should be there, right? So that's what is Docker here. It provides a container runtime. And another difference when we talk about Swarm and Kubernetes is Swarm can run only Docker, means Swarm can orchestrate only Docker containers, whereas Kubernetes can orchestrate containers from any runtime. In the beginning, when we are learning Docker, we were talking about this, right? Um, like Docker, you have other container runtimes as well, like Rocket, OCI containers, and so on. So your Kubernetes can manage containers from other runtimes as well. Docker is one such, but of course, it's very widely and very famous. So that container runtime should also be running on every worker node. That's the second component. Third component is the kube proxy, like which will take care of the communication or networking of the cluster. Like a container from one worker node may have to communicate with a container on the other worker node. So this kube proxy is the one which facilitates this. Got it? Understood? Any questions in these three components? Kube proxy will take care of networking or the communication within the containers or within the cluster. Cluster communications would be taken care by kube proxy. Those are the first three components. Are the first three components clear?
Yeah,
Yes,
Preethi,
ma'am.
yes.
Yes.
Right? So now let's go for the next component, which is pod. What is a pod, right? What is a pod? Like, how does it work? Let me tell you, in Kubernetes cluster, you will never see container like this. What does it mean? You will never see container like this. In a Kubernetes cluster, you will always see container wrapped around a layer called pod. This is how you see containers in the cluster. Means, like you don't deploy the container directly. Always there will be a wrapper around the container, which is called pod. Pod is like a living environment or home for the container. Container lives in the pod, and every pod will be assigned with some IP address, some network interface. Pod living inside the container will share the same pod IP, same pod network interface. It's like a home or a living environment for the container. And you will never see any container this way, a bare container. No, always you will see container in the in a pod, like a chocolate with a wrapper, right? The wrapper is like a pod. So also this pod is the basic or the fundamental unit of deployment in Kubernetes. Like you deploy the pods, you scale the pods, you replicate the pods, you delete the pods, you modify the pods. That's how you deal with the pods. Means that's a basic or the fundamental unit of deployment in the cluster. You will never deploy a container, scale a container. Of course, you scale a container in a pod. That's a different story. But this is the basic thing. Means the general or the best practice is one container per pod, right? But there could be multiple containers also. That's a far advanced use case or a rare use case. Like maybe if there are any helper containers which need to share some logs or something to the main container, there you may have multiple containers. Otherwise, it will be one container per pod, right? And uh, mm,
What is the purpose of the pod? Because we also do the same things with container.
yeah. So that's the question I have. Do you see any importance of it? Why do we need it? Any importance of this layer? How is this layer helpful? Why should we have this kind of layer? Anyone could have any guess?
Isolate the containers.
Okay. Okay, see this pod layer works like a layer of abstraction. A layer of abstraction which will abstract the containers. Means like just now we discussed, Kubernetes can orchestrate containers from any runtime. Like it could be containers from Docker, containers from Rocket, LXC, and so on, right? So this pod works like a layer of abstraction. So you deal with any container the same way, be it a Rocket container, LXC container, whatever it is, you deal with the container the same way. Meaning whether it is a Docker container or Rocket container, the way you scale them, the way you deploy them, everything remains same. So this layer of abstraction provides us an ease of working with any container runtime. Am I clear? Right. So those are the 4 components you have in any worker node. Like we deploy the pods, right? Till now, because we don't know pod, I'm talking about we deploy containers in the cluster, but actually it's a pod. So these are the components in the worker node. Now let's come to the components on the master node. See, these are the components you have, which is API server, scheduler, controller manager, and the HCD, right? So these are the different components you have in a control plane. And like control plane means master. API server. API server is called the core component or the major component of your control plane, right? And also like you run some Kubernetes commands, right? You may run them like using kubectl. Kubectl is a utility, means a tool with which you can interact with your cluster. So through the CLI, you can run kubectl commands, interact with the cluster. Or else there is also GUI in the cluster, graphical user interface you can have, through which you can deploy or run some commands. But GUI is very less used for Kubernetes. We use it very rarely. Majority of the times we use CLI. Also, if you know CLI, using GUI is self-explanatory. It's just where you see all the objects of Kubernetes on the dashboard. But whatever way it is, when you are giving some input through the UI or through the CLI, if you are running some commands, they are fed to the API server. API server is a core component, right, which will take these inputs, right? All the inputs will be fed to the API server. API server will take these inputs and it will validate those inputs, right? That's why it's called core component, or else it's called as brain of the cluster. Okay, so API server will validate it, and if it validates them, then it will talk to another component called scheduler. Scheduler, as the name says, it will schedule the pods on the worker nodes, right? So scheduler will have mechanism to see it will get the health of the pods, the resource available on the, health of the nodes. These are the worker nodes, right? So health of the nodes and the availability of the resources, and accordingly it will schedule which pod should be running on which node at what time. All of this scheduling will be done by the component scheduler, right? So that's what the scheduler does. There is another component called controller manager, which is very important component. Controller manager, as the name says, it's a one which have all the controllers like pod controller, replica controller, node controller, endpoint controller. What are all this you will see? So it will have all the controllers, and this controller manager works like a watchdog. It works like a watchdog which will run unending or non-terminating loops. Unending or non-terminating loops, continuous loops, which will check the uh, actual and the expected of the cluster, expected configurations of the cluster. Means, like, see, let's say we feed the input, right? As per this input, let's say I say I need, like, we need to deploy 4 pods. So this is called expected state or the desired state of the cluster, right? It will compare this expected state or the desired state with actual state. Means what is there in the cluster? Actually, there were only 3. So controller manager will keep on running some non-terminating watch loops, which will verify expected state across the actual state. So if there is any mismatch, it will again interact with the cluster. It will again interact with the scheduler and sees that the components are in place. Means this controller manager will compare this, and it will talk to the scheduler, and scheduler will schedule the one more pod to make it equal to the expected state. That's how these 3 components interact with one another and finally deploy the pod onto the worker node. Is this clear, everyone?
Yes, ma'am.
And you have to note a point here. Like in the Swarm cluster, whenever you deploy containers, containers will go to any node, right? Including manager. But here in Kubernetes, master node will be tainted. What is meant by tainted? We will learn. By default, master node will be tainted. Means you cannot run any load here. In all the pods will be going on to worker nodes only. Okay, master node will be tainted by default. So you don't need to, you don't get into running the load on master, because that's a bad practice. You shouldn't put any load on the master. Master should be a dedicated server which will manage the cluster, which will manage these components like API server, scheduler, controller manager, etcd. All of them would be installed on the master. Right? So that's how these 3 components interact. Can I go for the 4th component, etcd?
Yes, ma'am.
So etcd is like a storage, or else when API server is called as a brain, HC is called memory. Till now we were talking about, okay, scheduler will schedule a pod on the worker node by checking its resources and the health and all, right? And controller manager will check the actual state with expected state. How is controller manager getting expected and actual states? From where it is getting? How does scheduler know which node is healthy, which node it should deploy a pod? All of that information, these components will derive from the HCD. HCD is like a storage memory where all the cluster configuration will be stored. It's a NoSQL database. Means it will have the data stored in the form of key valued pairs. Data is stored in the form of key value pairs. Understood? So from here, all the components will retrieve the data. That's why HCD is very important and it's called memory of the cluster, where other components are relying on it for all this information. That's how these 4 components work together to deploy the load on the cluster. So if you are good with this, we can get started with the setup of the cluster. But before that, I would like to tell you, like, this is the cluster out of which master node has got a great importance. If master node is down, entire cluster will be down. So there'll be multiple master nodes. Also, there'll be high availability maintained for the master node. So there are challenges if you are maintaining your own, like your own setup on-prem, maintaining high availability of the master node will be an overhead. That's a challenge we have. But there are different ways to help with this setup or overcome these issues. We will talk about them. Now let's go to the setup, cluster setup. Okay, now coming to the Kubernetes cluster setup. This setup varies from environment to environment, and these are all the ways you can set up. Like there might be some physical servers, you can use them and create a cluster, like on-prem kind of cluster setup. Or else you may set it up on GCP, Google Cloud, or on AWS or on Azure, right? Any cloud, like you can do it. Now, if we talk about on-prem kind of, this is a bit complex kind of setup where you will install those components from the scratch. Means API server, scheduler, all of that should be installed from the scratch and you do it. The raw method of setup. And also in this setup, you have complexity of maintaining the high availability of many master nodes and all. So there are a lot of challenges with this kind of setup. So to make this setup a bit easy, you have an utility called kubeadm. So we'll install this kubeadm and using this, we can do the cluster setup. Right, this is what we'll be doing the cluster setup with. First of all, we'll do on-prem kind of setup using kubeadm. And on-prem kind of setup is having good demand in the market if you know this kind of on-prem kind of setup. Okay, this is how we'll set up. But then as we go for this, but we don't have on-prem servers, so how do we do that? We will take again some EC2 instances, but we'll assume they are like raw servers and we'll install it with kubeadm. Okay, we'll not use any other managed services for this setup. That's how we set up the cluster. And we will learn all the concepts here. Only the setup differs. Only if the setup is done, the concepts, everything, commands remain same. So we will do on-prem kind of setup. We will learn all the concepts here. And then there are certain concepts which we cannot do with our kind of lab setup. Like it's not a real on-prem, right? We have certain limitations. Those advanced features like auto scaling, which we can't do with our setup. Auto scaling, load balancer, right? These features we shall see on AWS. Now, coming to first, let's go each cloud one by one. GCP. You have a service called GKE, like you have EC2 service. There is GKE service, Google Kubernetes Engine, which comes like a pre-package. With a single click, entire cluster will be created. This is the easiest of all the cluster setups, and it can also help you create a prod grade cluster. Because Kubernetes is initially a product of Google, we have this flexibility or the ease of creating this here, and it's completely free. So if you are interested, you can also use this one. And coming to AWS, there is a service called EKS, Elastic Kubernetes Service, a managed service, a paid service, um, which you can use to set up your cluster. Again, on Azure, you have AKS, Azure Kubernetes Service, where again, I think it's paid, so where you can go for it. So I'm covering this paid managed service also on EKS to cover these advanced topics. And in the market, almost 50% of the clusters are EKS clusters. So you can imagine how demanded it is and how important it is to gain the knowledge. Again, being said that setup is only different. Once you set up, working with them is simple, easy. So that's why I'm covering on-prem as well as I'll also cover this. So you get also exposure to it. But it is a paid service. You should be taking care of those billing, like how much it will be billed and all. I'll discuss. You, if you want, you can just watch it. You can just do on-prem kind of setup, watch this and skip the hands-on. It's upon you. It's your interest whether you will go with the hands-on or not, right? But that's a paid service. Both of these things I'm covering. So this is the different kinds of setup, and we will progress with the on-prem kind of setup. Any questions here? So today we'll get started with the on-prem kind of setup. Like I said, we'll use EC2 instances, but we'll not use any managed service, and we'll use kubeadm to do the setup. Good to go? All right, then let's begin with the setup. You can have the cluster setup like if one manager and any number of worker nodes. Here I'll start with one manager and one worker node. And all the installation steps are there in the drive, which you can go with. Okay, now let me create two instances, Amazon Linux 2 instances, T2 micro, key pair is AWS. Worker node. Okay, so master and the worker will connect to them. Like I have created those EC2 instances, but I'm not using any managed service like EKS and all. Without using any services, with the kubeadm, we'll set up this cluster. So let's connect to them. This is the master. Okay, this is the master node. Let me open another tab for the worker. This is the worker. Okay, so now this is the master node and this is the worker node. To identify this, I'll change this terminal color. Worker node is in the green color. Okay, this is the worker node. Okay, and this is the master node. So now both of them should resolve the host names. Also, they can have some host names rather than this host name. So I'm setting a host name for them. It's not mandatory, but good to do that. Host name CTL, set host name as master node. Okay. I would like to set the host name of the worker node also as worker node. Okay. And this is the master node. They should resolve the host names with each other. etc host. Like put their private IP and the host name. Let's get the master's private IP. Okay. So let us do the same here. So that they should resolve their host names. Right, so these were placed both. They should resolve their host names, and the host names were changed. And now some OS specific commands we need to run. Like we were using CentOS nodes, right? There will be something called security in Linux, which is enabled. We need to disable it. So set enforce to 0. This will disable security in Linux so that those nodes can communicate with one another. Done. And for all these changes to take into effect, restart the system with the command reboot. So that once the restarted host name should be updated, and then we'll start installing Kubernetes. And let it come up. Right. So yeah, see, you can see the host name is updated. Similarly, let me check this node as well. Right, host names are updated. It is all good, perfect. Now let us install those components. Like we'll be creating some Kubernetes repository file because we have to install kubeadm. Okay, let me first list out the components. Kubeadm should be installed, kubectl should be installed, and then so these are the components we need. kubectl for interaction with the cluster, whether it is an on-prem cluster or AWS or whatever it is, kubectl is mandatory. And then kubeadm to set up the cluster from the scratch, and then Docker runtime and kubelet, right? These are the components should be done on every node. So we are going to install it. So to install these components, like we are going to create a Kubernetes repository file because they are not available in the yum package manager. So creating a repository file called Kubernetes repo. Now we can install it. And when you are installing it, make sure you are installing the right versions. Also install them both on the master and the worker node. Okay. And install the right versions. See Docker, kubelet, kubeadm, kubectl. And it's giving some error. Yeah. So the URLs got changed. So let me get a correct command, correct file actually. I just created the file again. So now it started installing. Do the same here as well. Now let us install the components. I think it was still using the old one. We'll see. So on master node, we have installed it. Once these are installed, start kubelet and Docker. Start them on the worker node as well. Now start enable those components. Enable Docker kubelet. Okay, so done. So now everything is ready, all set up with all the components. Now we can start Kubernetes. How do we start Kubernetes? Actually, whenever we are creating the cluster, the basic prerequisite is each node should be having 2 gigs of memory and 2 vCPUs. But if you see here, the T2 micro, we are having only 1 vCPU and 1 gigs, which doesn't suit the requirement. But yeah, for our lab, that's enough. We are going to create a cluster with it. But during the cluster creation, it may stop throwing an error. So we have to stop this with this flag. Actually, it's incorrect. You have to provide the IP address of your master. Here IP address should be, you should run this command on the master node with IP address on the master. I just want to change this. See, ignore pre-flight errors of CPU, memory, and some pod network. Every pod will be assigned with some IP address. So I'm giving some pod network IP range. So this is how you have to start your cluster. You have to run this command on the master node, kubeadm init, API address, and ignore pre-flight errors regarding CPU, memory, and provide some pod network range. This is what we have to do. So that should create the cluster. And this master worker node will communicate with the master on port 6443. And we can enable the security on that port or else allow all traffic. I'm allowing all traffic for now, so that they can communicate. So let's see. Yes, you can see here all the components were ready, cluster is ready, it says, and we are installing this as a root user. But always root user access will not be there. You should run it as a regular user. So as a regular user, you should be creating a kube config file, right? So run the token command this way. Kubeadm join. This token should be run on the worker node. Actually, we should correct it and run. Before that, like I said, whenever you create a cluster, config file is created in this path, etc kubernetes admin.conf. But this is required for authentication for other users. So as an EC2 user, you can run these commands. Create a directory called .cube and then copy admin.conf into .cube config. On this config, right? So yeah, like now as an EC2 user, if you run kubectl get nodes, that's how you see the list of the nodes. See, we can see that master node and worker node is not yet added, right? It get thrown in an error. So we have to run this. Get the token again. This is the token. Remove any unnecessary spaces and run this token. Let me just I'm just editing this to remove all unnecessary spaces. On the master node, right? You can see like it's connecting, right? This says this node joined the cluster. Now, if you see get nodes command, yes, you will see two nodes. Do you see that? Right? You can see two nodes are added into the cluster. One is master, other one is worker, but it says it's not yet ready. One more thing is, we have configured, kubeadm have configured all the components. You will see them using cube, you will see them as a pods. You can run the command kubectl get pods -a. -a means it will show you all the pods on the cluster. See, core DNS, HCD, do you see that? If you are installing something on a cluster, you will install them as a pod. So you can see those are all the pods running. Some of them are on pending state, right? Also, to facilitate their communication, we need to install some network plugin. So let us install that network plugin on the cluster. What is the supply command? You will see later. Just install those components, the network plugin, and we are installing Calico network plugin. There were many network plugins, out of which I'm installing Calico network plugin. This will start few more additional pods. See here. Until they are in running state. See, they are in pending state, Calico plugins, core DNS and all. Until then, your nodes will not be in the ready state. Once all those pods comes up, then your node will be in ready. See, it's ready, but master should still come up. Let's wait for all the pods. See, pending, container creating, pod initializing, and then they come to running state. So let's wait. See, some of them are in running state now. All of them should be in the running state. Right, all the pods are in running state. And now if you see, get nodes, they are in ready state. Right, now, yeah, now the cluster is ready. Any questions from anyone here? And you have to do this setup very clearly. Follow the same steps, like how they were in the drive. Just follow the same steps and you can set up it easily. Any questions? Okay. So cluster is ready and you can start your own pods, like your application pods, your Nginx pods. You can do all of that here. And yeah, like I said, we always prefer declarative approach. Like we write a manifest files, but I'll show you an imperative approach with a one-line command. kubectl is the one with which you interact. Run, let's say sample pod. Pod name is sample pod. Image name is Nginx. Isn't it? How do you get a pod? What is inside the pod? You have a container inside the pod, right? So pod means container will be created with an image. So kubectl run sample pod image name Nginx. This will create a pod called sample pod with the image Nginx. Is this information clear for everyone? Is this command clear for all?
Is this also create the container or only the pod?
What is inside the pod? Container, right? So yes,
Container,
we
yeah.
create a container with a pod layer above it. And the
Okay.
pod name will be sample pod.
And what is the container name?
We are not giving any name to the container here. If you want, we can give some name to the container.
Okay, okay.
Now I'm running this. It says it's created. Get pods will show only the pods in the default namespace. See, it's in container creating. In few minutes, it should be running. Yes. And if you want to see all the details, describe a pod, type of the object. Pod is an object in Kubernetes API. Name of the object. As it is only one pod, you don't need to give the name. If you give like this, see, this is the container ID assigned, right? And you can see sample pod inside the containers. Right? And here you can see what all happened. We learned in the architecture, right? What happened actually? It assigned the pod to the worker node. Then it pulled the Nginx, successfully pulled this Nginx in these seconds, created a pod and started the created container sample pod. Container name is also sample pod. Actually, the container name also is same, right? And then the started the sample pod, right? This is the name of the pod as well as the container. And
Preethi, pod
every pod will be
pod
assigned. Every pod will be assigned with this pod IP. Yes, please go ahead.
Pod IP address and container IP address will be same or different here?
Same. Like container will share the same pod IP, right? So yes, this
Yeah,
is
okay.
the IP or
Yeah,
pod
if
IP
it is one pod having the 3 container means all 3 containers will be same IP address,
on different port.
different port. Okay.
They'll use different port. And when you do with output wide, you can see on which node it is running. As of now, it's only one worker node. So it is showing the worker node where it is running. Pod IP. Is this much clear for everyone?
Yes, ma'am.
So that's how you create a container. So this is our cluster, right? I would like to show you one more cluster setup. Like we were talking about these things, right? Like on-prem GCP and all. So there is also another kind of setup, another cluster called Minikube. Minikube is a single node cluster, right? But which will help you for learning or like a playground, you can use it. It's not for real time, but for your learning, you can use it. Setup is very simple, so you can quickly set up and go ahead with it. Let me show you. You can install this cluster in multiple ways, like Minikube. There is official page for Minikube cluster. So either it is Linux or Mac or Windows, you can choose and accordingly run the commands. If it is Windows, this is how you set up. If it's Linux, on Linux machine also on single EC2 instance, you can set up this. Or else on Mac, this is how you set up. I have done my setup on Mac using this command. Now, if I want to start, I have to start this way. Let me show you that, okay? Because that will be helpful for quick hands-on. Minikube start. That's all, as simple as that. But of course, Docker should be running for it. So we have installed Docker desktop. Do you remember that? I have shown you Docker desktop, right?
Yeah, yes.
Thank you. Thanks for confirming. I just want to recollect maybe whether I have missed it. If no response, I'm just thinking whether I have shown it or not. So Minikube start after starting Docker, either it is on Windows or Mac. So you can have a cluster created and you can just work with all the Kubernetes concepts on it. It would be better, easy setup because as we progress, we are using T2 micro instance. It may not be supporting certain features, particularly the advanced feature like help. In that case, again, we can use Minikube there. So without any hassle, if you want to use, you can go for this Minikube. Okay, Minikube cluster is started. Now again the same. Of course, kubectl also you should install. Kubectl get pods. See, already some pods are there for me. Let's say I will run the same command. Kubectl run sample pod from image nginx. Concepts, commands, everything would be same. It says it is created. See, this is the newly created one. It's container creating states 4 seconds back. It should be up very soon. Right? So now it's available. Again, commands are same like a describe your pod. Because there are multiple pods, it will describe all the pods. See, all the 4 pods are described. Do you see? So if you want to describe only specific pod, give the name of the pod. Only that pod is described. Again, architecture wise same. If you want to see where it is running, kubectl get pod with output wide. See, each pod with its own IP, and the node is Minikube because it's single node cluster. It provides a simulate the environment to learn Kubernetes. Are we good? So now whatever you run on this on-prem cluster, you could also test it out here parallelly if you are interested. Or if you just want to go with Minikube also, you can do it. Concepts, commands, manifest files doesn't change. So it's up to you to choose where you want to do the hands-on. And we have created a pod this way, like using this. This is called imperative command. Imperative command, a quick command, single line command with which you store it. But you can't manage the history of it. You cannot reuse it, right? So rather than this imperative approach, Kubernetes prefers declarative approach, where you write your manifest in the form of JSON or YAML. So that's what we have to step in. Any questions till this much from anyone? So, like we'll get started with this in the next class, writing the manifest files. Until then, have your cluster setup done and ready. Any questions you have, you can feel free to ask now.
Ma'am, a pod can only store a single container or ma'am multiple container?
Generally, one container, like single
Okay.
container, one container per pod is the general practice or the general use case.
Okay.
All right, then we'll close here and we'll continue tomorrow. Thank you all. Good day. And one more thing is, sorry, I think I stopped sharing. Please wait. So you have created these instances. Like any other instances, you can stop it and start it next time when you start working. Same like any other instance. Cluster will still work. Okay, but don't keep them or leave them running. All right then. Thank you all. Good day. See you tomorrow. Bye everyone.
Thank you.
Thank you all. Bye.